Math Chapter 3, Fractions and Mixed Numbers. So we're going to take a few minutes on this chapter to review and recall prior knowledge. So one thing to remember from previous years is that like fractions have the same denominator. Remember, the denominator is the number on the bottom. So if Liam had 2/5 of the cracker and Walt had 3/5 of the cracker, 2/5 and 3/5 are like fractions because they have the same denominator, which is 5. Unlike fractions have different denominators. So like this one that had in one box 3/4 of a pizza was left, and another box 2/5 of the pizza was left. So they have different denominators, 4 and 5. All right. And a mixed number consists of a whole number and a fraction. So this one with the melon, it has 2 wholes and 1/2. And there's a whole number of 2, a fraction of a half, and here's the mixed number, 2.5. Also, you'll remember from 3rd grade about finding equivalent fractions when you're changing something where you're changing the denominator. So like you want to turn 4 into 8. So you're going to multiply the denominator by 2. 4 times 2 is 8, and multiply the numerator. 3 times 2 is 6. Or you can also divide when you're finding equivalent fractions. So say you have something that's in 12ths and something that's in 6ths, and you want to compare them, you can change 8/12 into 4/6 by dividing both the denominator and the numerator by 2. So also you've learned, I believe in 4th grade, about expressing fractions in simplest form. So in order to simplify a fraction, you divide the numerator and denominator by their greatest common factor. So in 6/9, 6 and 9 are both multiples of 3. So if you divide by 3, you get 6 divided by 3 is 2, 9 divided by 3 is 3. So 6/9 can be reduced or simplified to 2/3. Also with 8/12, you can't divide 8 by 3, even though you can divide 12 by 3. So you know that that's not their greatest common factor. You can't divide 12 by 8, but both of these numbers are divisible by 4. So that's their greatest common factor. 8 divided by 4 is 2. 12 divided by 4 is 3. So we end up simplifying 8/12 into 2/3. You also learned in the past about representing fractions on a number line. So if this is 0 and this is 1, and it's broken up into 12 pieces, you can put on here 12ths, like 3/12, and you can also put 6ths and 1/3s and halves and 4ths. You've also learned how to identify prime numbers and composite numbers. 2 and 5 are prime numbers because they have no factors other than 1 and themselves. So 2, its only factor is 2 times 1. 5, its only factor is 5 times 1. 8 and 24 are composite numbers. They have factors other than 1 and themselves. So 8, one factor is 1, one factor is 8, another factor is 2, and another factor is 4, because 1 times 8 is 8, and 2 times 4 is 8. So these are all factors, 1, 8, 2, and 4. 24 has more factors. So you can get 24 by multiplying 1 times 24, or by multiplying 2 times 12, or 3 times 8, or 4 times 6. These are all factors of these composite numbers. Also, you learned about expressing improper fractions as mixed numbers. So you can express 5/3 as a mixed number using models such as this. So if you have thirds, you have 3/3 and 2/3, which is 5/3. You can write it as an improper fraction, or you can switch it over and say, okay, 5/3 is the same as 3/3 plus 2/3. 3/3 plus 2/3 is the same as 1 plus 2/3, which is the same as 1 and 2/3. You can also use division. So if you don't need a picture model and you want to use division, you can figure out improper fractions this way too. So 5/3 is the same as saying 5 divided by 3. So you have 5 here, you divide it by 3. you get 1. So 1 times 3 is 3, minus 5 minus 3 is 2. So that's the number of thirds left over. So you have 1 and 2 thirds. Also, you used bar models in the past to add and subtract like fractions. So these ones both have a denominator of 9. So you can add 2 ninths and 4 ninths really easily just by looking at the numerator. 2 plus 4 is 6. So you have 6 ninths. You can reduce that to 2 thirds. 9 tenths minus 3 tenths equals some number of tenths. You can do this on a bar model and just count. So 9 tenths minus 3 tenths is 6 tenths, and you can reduce that to 3/5. You also learned about adding and subtracting unlike fractions. So 2 thirds plus 1/6, you learned to make both of these to change them so they had a common denominator, so that they both had 6 as their denominator. So 2 thirds is the same as 4/6. So 2 thirds plus 1/6 is the same as 4/6 plus 1/6, which is 5/6. Here's another example with ninths. We're not going to go through all of it. You can do the same thing with subtraction. So here you have denominators of 4 and 12. You're going to find the common denominator being 12. So that would turn into, you would go 4 times 3 is 12, 3 times 3 is 9, and you would end up with this, 9/12. And now you can do the subtraction. So 9/12 minus 5/12 equals 4/12, which can be reduced to 1/3. There's another few examples that you can look at in your book if you need. You guys do have a lot of prior knowledge about fractions. 2 more things we're going to review. So reading and writing tenths and hundredths in decimal and fractional forms, you can switch back and forth pretty easily between decimals and fractions when you have tenths and hundredths. So 1/10 in decimal form is 0.1. You read 0.1 as 1/10. 1/100 or 1/100th is 0.01 in decimal form. So it looks like this. It's a fraction of 1/100th, or it's written as a decimal like this. This is what it would look like in blocks. So you read 0.01 as 1/100th. You can also express other kinds of fractions as decimals. So if you were expressing 9 tenths as a decimal, if you know that 1/10 looks like this, 0.1, you know that 9 tenths would equal 0.9. If you had 17 hundredths as a decimal, you know that 10 hundredths equals 1/10. 17 hundredths, you have 1/10 and 7 hundredths. So 17/100 equals 1/10, 7 hundredths, and it can be written like this, 0.17, because you have the 1 in the tenths place and the 7 in the hundredths place. So I'd like you to go through and do the quick check problems for this chapter, simply because fractions are one of those things that kids tend to struggle with in the earlier grades, and it's covered, but it's maybe not taught for mastery. So you might have learned it a little bit, but you might not have mastered it. So I want you to go to pages 170 and 171 and just double check for yourself that you're remembering how to do all of these things with fractions so that you have a base and are ready for the next learning in the chapter.